It's a pleasure to be here this morning. And one of the disadvantages of coming last in a sequence is that the previous three speakers have already said everything that you were going to say. So by necessity of a throat which might give up at any moment, and the fact that most of it's already been said, this might be a little bit shorter, which might help Stephen get back on to his track. And I assume it's that one. So this is definition number 28, I think we got to. And this is our definition. Now, one of the issues about working for Mott MacDonald, which just in case the name is not that familiar, we are a major infrastructure consultancy. So Mott MacDonald boasts, or otherwise, around about 16,000 staff working in professional services on advising. And one of the things that you're not allowed to do in Mott MacDonald is stand up in front of an audience unless you know the answers to all the various questions. I have a pretty unique job in Mott MacDonald, is that I'm allowed to stand up and say, not only don't I know the answers, we don't yet know most of the questions. And my role in climate change, and I just wish I could have taken the role of Director of the Future. I think that's a magical role. But anyway, in terms of my role, I head up a team within Mott MacDonald looking at the issues that are embedded in climate change. And because talking about climate change is even worse, we settled on climate resilience as the factor that we're talking about. And this was our definition. Now, to help along, I've sort of shaded and colored the climate-related comments. So if you just subtract all of those, delete any reference to climate, then actually the definition is still pretty sound. It's adapting infrastructure. We're an infrastructure company, but actually it's infrastructure and society to the impacts of climate change, well, to the impacts of change, to the impacts of shock, to allow the businesses and the systems and the community and society to change, to evolve, to adapt, actually to be better and stronger for the resilience interventions than they would otherwise have been, and come back to that a little bit at the end. I'm going to frame these comments in quite a general sort of scale and quite a global scale, and hopefully maybe even shock you a little bit with some of the size of the numbers that we're talking about, which again might then help to frame the UK in a global situation. But globally, there's a pretty straightforward. So I did it in 4x3 format, but obviously that doesn't work. There's a pretty standard model for infrastructure development that we make, and that's supposed to read investment decisions, to create the finance, to implement the policy and the standards, to create infrastructure. So this is bad for the rest of the slides, but never mind. To provide the services that we were meant to be providing. And actually, the fifth arrow is missing because, of course, this just goes round and round the loop. That we're making investment decisions to provide the money to implement what we believe we need to implement through the creation of infrastructure to deliver the services that society as a whole requires. So that's fine. The issue is that we are increasingly shocking and stressing those decisions by two key aspects. That society as a whole wants a better tomorrow than today, and that's not the subsistence farmer in Africa, or not solely the subsistence farmer in Africa, that's also the penthouse dweller in New York. Everybody wants a better tomorrow than today, and actually there are more of us wanting a better tomorrow than today, increasingly day by day. So we are stressed across the issues of social development and population growth. And these in themselves are considerable drivers towards urbanization, which gives us the issues around cities, which gives us all the current resilient cities initiatives, of which the Rockefeller Foundation is leading the cause. And if you look at these big global numbers, and you know, I prepared to argue any of these numbers with anybody. I'm not going to say they're right, but they are of the right sort of scale. that we're currently looking at an asset base, an infrastructure base around the globe of this sort of number, 20, 25 trillion, maybe 30 trillion. We are facing, because of these two drivers of population growth and social development, an unprecedented rate of infrastructure provision over the next 2 to 3 decades, which the industry, that the press suggests is in this $3 to $4 trillion per annum category. Massive amounts of investment. If you then cast forward 2, 3 decades, 20, 30 years, then 60, 70, 80, maybe 90, maybe $100 trillion is going to be the asset base. So what's vulnerable in our society is going to increase massively. So, as well as better and more, we shock our systems, or are increasingly shocking our systems, through climate change. Be it the acute events, the severe weather events, or the chronic changes. And I think this speaks well to what you've heard so far this morning, but I will come back to it and touch it in a minute. And under these scenarios, we are already experiencing losses due to climatic events of round about $100 billion per annum of economic losses. So not simply physical losses, but broadening out to that. And the hypothesis that we are promoting and we are delivering is that if you accept the rate of change in the asset base, such that the problem is going to get bigger, and you accept that the climate change issues are going to get worse, then over the next 2 to 3 decades, we're going to see that $100 billion per annum loss escalating towards the $1 trillion. And if you go back in the slide a little bit, where we're talking about investing only $3 to $4 trillion per annum, then losing $1 trillion per annum is really rather significant and actually unaffordable. I'm wary of this with the professor in the room, but a simplified version of statistical analysis on any climatic event, that you get a distribution, something like this. And being good engineers, which we all are, and I indeed also am a civil engineer, we would design at the far end of the curve at something like a 90 percentile or a 95 percentile, and we would accept that an event beyond that design criteria is going to give us some issues. What we're seeing in climate change is essentially this, that we're seeing relatively small changes in the mean distribution. The curve is shifting to the right, but that small change in the middle is giving us an exaggerated change at the extremity. So we get more severe events, and we get them more frequently. And in the climate change terms, this is the chronic change, temperature rise, sea level rise, against the acute events, both of which are damaging to our infrastructure. And I say again, we are an infrastructure company. Now, I carefully wrote some notes through the other speakers, which I've so far ignored, but here we come back to them. So in terms of these shifts, so about 12 months ago, DEC in the UK issued their climate model. And it was a model to play scenarios on how principally the energy mix and food mix could reach a 2 degrees C maximum ambient temperature rise. At the same time, the World Bank issued a report saying 3.7 degrees. And I think currently we sit around the 2.7 mark, having said, well, 2 is now actually quite unlikely. 2.7, 3, 3.5, 3.7. By the time we're looking at anything approaching 4, then the current projections we've made about losses you can throw out of the window. Because by the time you get up to that sort of level, the changes on our society as a whole are going to be substantive. In terms of global risks, the current view, and this is not my view, this is a current view, is that you can look at these in 3 different brackets, if you will. Physical risks is really rather straightforward to imagine. You have a flooding event which causes some damage, and you've got something that you need to repair if you're going to put society back to where it was. But as we look at these things, you think, well, actually, that physical risk is not simply it, that we're then talking about liability risks. And we're talking about the insurance risks, the reinsurance risks. Who covers the cost, not only of the repair, but of the loss of service during the repair? And this is gaining increasing issue that this is significant. And then finally, you're looking at what is currently termed the transition risks. So all the investment that we're currently making and is ongoing across the globe in a less than low carbon economy, petrochem industry, coal-fired power stations, which is still happening, there is a huge risk that as you move increasingly towards a low carbon economy, all that investment becomes stranded. It becomes commercially and financially inviable and actually is a waste of money. And the issues that we've got around all of this is that with this level of investment that we need to make, we can't afford there to be a waste of money. We have to get it right. There's a gentleman who crops up occasionally on the world stage who's not exactly renowned for his laugh-a-minute sense of humor, and this is Mark Carney. And Mark Carney made these comments in a speech at Lloyd's 2 or 3 weeks ago, pulling these issues forward. Now, for the audience that he was speaking to, which was the global insurance and reinsurance market, to use phraseology like the far-sighted amongst you. Now, so that's really throwing the challenge down to the audience. Do you regard yourself as far-sighted or not far-sighted? Up for the audience to choose. But Mark Carney was in no doubt that this is a significant and substantive global issue. So we have a flooding theme, and just to show 2 or 3 pictures, because my voice is just about to give up, there's no sector immune from this. So this is the floods in the UK, 2007. This is a livelihood representation from Africa. So this is not excessive water, this is now lack of water. Huge impacts on food production and rural livelihood. Urbanization issues, yes, you can get people in the cities and you can protect them to a degree, but if your building codes are not sufficient, then you're going to reap damage. And the current view of the federal government in the States is that if their building codes had been stronger, this sort of damage would not have happened through Superstorm Sandy. That's Thailand, and that's Nissan's car stockyard, new car stockyard, not scrappy stockyard. These were ready for delivery from Thailand, now no longer simply a food production area for Asia, but in the urban economy, a relatively low-cost place for global manufacture. And if these places continue to be vulnerable, we make our global systems vulnerable. And critical infrastructure. Now, okay, this was earthquake. Earthquake produced tsunami. Tsunami overtopped a wave wall, which had been reviewed relatively recently in the past and decided not to raise it because the asset was close to its useful life. They didn't actually appreciate how close it was to the end of its useful life because there wasn't much left of it. This is Fukushima B. And the consequences of this is it didn't just take out a nuclear power plant, as disastrous as that was, it put a stop to Japan's nuclear industry. It had knock-on effects into Germany, which had knock-on effects into the UK. So we increasingly see this interconnection of systems that, yes, we need multifunctionality, I agree, but we've got to be careful that we don't create too much interreliance. Interconnectivity, yes. Interreliance, be careful, because you're then outside the framework of simply protecting your own assets. You're into the framework of then protecting your supply chain and your delivery chain and society as a whole in which you function. This is our model of resilience, and again, I'll put my hand straight away. We didn't create this. This again is taken from the literature, but we sort of like this. We sort of adopted this. And the 4 R's of resilience, although it should be 3 R's and 1 F, but we'll come to that in a second. Top left-hand corner, robustness. So this is somewhat the old style of building stuff to withstand the shocks that we have in place. And against that, diametrically is not designing to protect, but actually designing for recovery. So this is a shift in engineering practice away from making sure something isn't damaged to actually saying, we don't mind if this is damaged, The issue is how quickly can we get it back into service operation. So concrete can flood, electrical switchgear tends not to flood terribly well. So you tend, if you want to design for failure, you make sure your electrical switchgear is above the flood level. Simple issues, but complex in its full issue. And then we looked at redundancy and resourcefulness. Resourcefulness really should be flexibility, but flexibility doesn't begin with R. And this is how much standby facilities do we put in place, and how much can we move our duty points around our system that we have. And our view simply in terms of resilience is that there is no textbook answer to this. There is no simple mathematical formula which says you take, well, 2 of those, 3 of those, 4 of those, and 1 of those, and hey presto, that's the answer. The answer to this and what you invest in resilience is going to depend on any given particular set of circumstances, location, service, vulnerability, etc., and all needs analysis. We do believe quite strongly, and this goes back to the definition, that there's an upside to this, and I believe this is the last slide, Stephen. So if we assume that we have a business, or we have a service, or we have an asset, then it has, on this particular curve of provision against performance, it has a value. It is in being, it's performing, it's functioning. We then kick that with a climate impact. And we suggest there are 3 broad brush scenarios to this. The aptly named crash and burn. So you have a system, you have an asset, you have a business which does not survive that impact. Doesn't survive the flooding incident because it can't get itself back together, because it didn't have insurance, because there is no pickup. It doesn't survive. You might have a scenario that you get this survive and stumble. So yes, you can get the business back in operation, you can get the service back up and running, but there are substantive and long-lasting and ongoing detrimental impacts of that incident. And we don't think that's being resilient. The view that we would take is that there is a prosper and growth option to this, of correct investment in resilience, correct resilience planning should allow you to be in a position, yes, you will suffer the impact, but to get back quicker, more effectively, and from a commercial point of view, actually make hay while some of your competitors don't, and from a social point of view, just to get better than you were before. So the last time this happened, it was out for 5 days, and this time when it happens, it's out for 5 hours. And that, in our view, is the definition of resilience, and the resilience dividend, anything where we're seeing that improvement, and a deficit, anything below. And I think it goes back to one of the earlier comments. This is not a question of if the next severe event happens. It's only when, and how often, and how bad is it going to get. And our view is that it's going to be, at any time, quite bad and getting worse. The route to resilience, and final comments, this requires collaboration. This requires the interaction that the other speakers have already talking about. Ditch the solo mentality. Everybody needs to put on the table what they've got to move society forward. From our point of view, this is an issue of managing risk and uncertainty. The only certain thing is that these events are going to happen. When, how frequent, how severe, in what sort of circumstances, and what happened yesterday, and what happens tomorrow, that's where the uncertainty lies, and that's where we probably need to use scenario planning and scenario modeling a little bit more. Build own internal capacity at each and every level, service provision, business, etc., and know where the vulnerabilities are in your extended market chain. So that's not just your assets, not just your supply chain, but actually your delivery chain. If you can't sell what you make as a business, you have no business. And understanding where those limits are to your vulnerabilities, and our endorsement, our encouragement to service providers, to governments and the like, businesses, is to look for the resilience dividend. Thank you very much.